First example, pipe bench is support at point A, that is a point A, and connect to the flow system by flexible cropping at section 1 and 2, that is section 1 and 2. The fluid is incompressible and ambient pressure PA is 0. Okay. Find expression of torque, okay, that must be resisted by the support at point A, that is point A, in terms of the flow property at section 1, 2, and distance h1, h2. So we want to find the torque. At point torque TA is a function of the area of velocity or h, okay, that is the at point 1 and 2. Okay. Next step, we have to make the control volume. Okay, we draw the green line cover the pipe bench. Make sure that at the point 1 and point 2 is 1.1 and point 2, the boundary of the control surface should be perpendicular to the velocity vector, okay, at v1 and v2. And and so we have force P. At this point we have internal force from pipe P1A1 and P2A2, and this is torque at the point A that we want to find relationship. If we look at the change of momentum at the point inflow and outflow, we can see that for the angle theta1 between R1 and H1 and angle theta2 between R2 and H2. So we can write that H1 is R1 sine theta, and in this case H1, in this case R1 cross V1 equal to V1 R1 sine theta. So we can substitute R1 sine theta, so we got V1 H1 for cross vector between position vector R1 and V1. And outflow as well. So R2 cross V2 is equal to R2 V2 sine theta. So we can write that for space. Connected for R2 V2 is equal to R2 to V2 H2. Okay. And next we write the equation of the angular momentum. This one, the change of momentum, angular momentum inside the control volume, and this part is a summation of at the outflow and inflow. Okay. For this, for the change of momentum inside control volume is going to be T0. Okay. And for this term, we say that the mass flow in and flow out is the same. So we can combine that, so it's equal to V2 H2 m dot subtract V1 H1 m dot. The next we find the equation for R cross F, summation of R cross F around point A, if we assume that anticlockwise is positive. So how many force we have? We have torque TA, and we have one from P1A1 with the R1. This is R1 and this is R1. Okay, P1. Another one is the outflow R2 cross P2A2. Okay, and next is for R1 cross, we got the P1A1 sine theta. For R, we can substitute that for R sin theta 1 is equal to H1. For R sin and P2A2, R sin theta 2 is equal to H2. Okay. And the next we substitute in the first equation. So we that on the left hand side TA plus P1 A1 H1 subtract P2, okay, equal to M dot. Okay, and then we can rearrange to get what is equation for TA. T equals to move A1 H P1 H A1 H1 on the right hand side. Okay, we make a new group, grouping the H1 H2 together. So we H1 times H2 times P2A2 plus the M dot H M dot V1. Sorry, M dot V2 and subtract H1 P1 A1 plus that is the equation for torque at point A.